Hi, this is Karen O'Brien, and I wanted to start with the second video in this infiltration mapping and modeling series. Well, it's not really modeling, it's more like infiltration mapping and processing. And we're going to start with two infiltration calculators, and that is SCS, curve number, and the Horton method. Okay, so we're going to start with the Horton method. It's the simpler of the two. Well, not really, but you'll see what I mean. And so you check your global checkbox, and then you set up some global parameters because you have to have those in the data file. So I just set up some generic parameters because I'm not going to use uniform global. I'm going to override these global variables with my local variables. So if you wanted a single uniform variable, you would just use these guys right here. And you click OK. And then you would export your infiltration data, and it would give you that data as just a global data. But what we'll do is we will develop infiltration data onto the map. Now this is kind of difficult for Horton. Not really difficult, just different. Because Horton is the only tool that requires you, or only infiltration method that requires you to build your infiltration data into this box right here called infiltration areas. And what this does is it's going to give you polygons in this group that delineate the Horton infiltration rates and allow you to apply Horton, or allow you to apply those to the grid. This is Arizona, not Denver, so we don't have like maybe a good infiltration map here, but we do have the ability to kind of, what I've done here is I've taken this infiltration data right here. Let me turn these guys off. And this came from the curve number generator, but what I did was I took a kind of a reference manual and I extracted, like I just guessed from the curve numbers, what the Horton infiltration rates might be. Now I didn't guess, I just used kind of like a conversion tool or a conversion methodology. And so if it had a specific curve number, then I gave it a initial Horton infiltration rate, a final rate, and a decay rate. And the key to this is you also need a field here called name with an individual name for each row. So this is actually really easy. You just hit edit and you add a field and you call it name, and it has to be exactly this capitalization. And you set that to string and you click OK. And well, let's just do one. I'm going to call it name 2 though. Name 2, and we'll make that string and click OK. And then we are going to fill that with something very simple. We'll open quotation, single quotation mark. We can just call this H dash, close quotation mark. Actually, we need concat. Let's do it with the expression editor because it's a little bit easier and more visually helpful. So if you open, and first of all, I'm so sorry, I got ahead of myself. I need to set this to name 2, and then I can open the expression editor. And I need to search for concat. And you have many different concat abilities, abilities to concatenate things, but we want string. So you double click on that, and then the first string will be the first part of the name. So in this one it was Horton, but I can just do H dash, well, I need the open parenthesis, open single quotation, H dash, close quotation, comma, and then this is just a row number. So if we come in here, we take row, we can just put in here row number. And then you close your parentheses, and you can see right here, this is the preview of what you'll be filling into that data. And if I click OK, you can see that that's a very simple expression, and you can just update all, and it's ready to go. And that would be your name field. Okay, and it's as easy as that. And that gives you, now the reason but we have to use this one, right? Now watch what happens, and I'll show you right now exactly why we have to use this one. So now if I open this table, let me grab the other table back up too. You can see that I have a name here and a name here. These two match exactly. So when I copy data from this layer into this layer, it's going to fill this field. Now if these three fields also matched these three fields in exact name, they would also fill those three fields. Or you could simply do your editing. You can click this field and you can draw your own polygons and fill your infiltration data that way. It's pretty simple to do it that way too. But in this case, I had this data that I already had processed, so I want to use it. So what I'll do is I'll select this layer, and then I will use this tool called Select All Features. I'm actually on it because I use it regularly. So I select all features, and then I Control C to copy all of those features, and it's going to copy the geometries and the tables. And then I come to Infiltration Areas, and I click the Editor Pencil, or you can right click and click the Editor Pencil here, and then I click Control V. And you can see that that is going to paste 1,171 features. And then I can click Unselect All from all layers. Okay, and now you can see that I have copied these features from this layer to this layer, but I did not copy the attributes because hang on one second, let me get over here to my Horton attributes, because these attributes, these fields didn't match. So but my name field did match. So it did cross over. So that means we can now set up a join, and we can join data to this table. So I'm going to click Save, and then it's going to take a second to commit those records. And then I'm going to right click or double click Infiltration Areas, and I'm going to set up the join. Okay, the join is very simple. You just click the plus arrow to create a join, and we want to join it to this layer. So if I click the drop down menu and I hit the I key, that takes you down to the eyes because they're alphabetical, and you can just move down until your eyes are more visible. So my eyes are right in here, and I want to join to this layer, and my join field is name. That's because those two fields have the exact same variables in them. And I can click Join Fields here, and then I only need the infiltration rates, and I can use this as the custom prefix name, and instead of this as my custom prefix, I'll just put in an XX underscore, because I don't want it to be a really long value that I have to, expand the window to see. And I click OK, and I click Apply. I don't actually think you have to click Apply. I think you can just click OK. And then if I come back to this table, that's this guy right here. Nope, that's wrong. That's this table. You can see that I now have these three tables: initial Horton, final Horton, and the decay. And they're in the correct location, but now I need to move that data to these three fields. And that's really easy. So if I set this to Horton I, which is initial, I can set this to initial Horton, and then I can just click Update All, and you can see that it'll just copy those values over to here. Then I go to the next one, that'll be Horton Final, and I set this one to Final Horton, Update All, and then I set this one to Decay, and I set this one to Decay, and I click Update All. And now all of these three fields have the Horton data applied to them. And so I can click Save, and I can click Turn off the editor, and then I go back to the layer properties and delete the join, because joins will slow down everything. So especially if you have a lot of grid elements, it's gonna slow down everything. And then I click OK. And now I'm actually finished with this layer, so I can uncheck it and turn it off. And then I come over here and I click Schematize Infiltration Polygons. And the only thing that it's doing is it is sampling those polygons from the centroid of every grid element. And you will see that now I have Let's see if this is showing up. Let me click center. Now you can see that you can see that this box will show you those Horton fields. And this, of course, comes from the curve number generator, because that's where I got this polygon map from. And then I just, converted it into a Horton map. All right, so let's see what happens when you okay, so let's do this. Let's go infiltration areas, and then we'll use the ID tool, and then we'll click on this, and you can see that for this grid element, the Horton was 78, 60, and 0.02. So if I use this tool and I click on, that's grid element 167, and if I go to, now I'm going to check that grid element in the table so that you can see how this worked. Now if I go, I need extra tables, okay, so let's do this. We're going to collapse all, and then we're going to open the self-help kit layer like this. And now what I want to do is turn on, I'm going to use Flow 2D settings to turn on the advanced layers. And now you can see all of the hidden layers. We hide them because you don't typically need to use them. And in these infiltration tables, we have this attribute table right here, which is Horton. So if I sort this by grid element number, you see that some grid element numbers are missing. And that's because we don't have complete coverage of this map. And that's because when I created this map using the curve number generator, my grid was a little different. My grid was a little bit smaller, and it didn't account for these guys. That's okay. I'm going to show you how to sort that out. But I did want to show you that grid element number 167. So if I select this guy right here and I just put in there quickly the number key 167, it'll take you right to that, and you'll see that it matches 78, 60, and 0.02 is the decay rate. So these are the infiltration parameters for that polygon. And I'm going to leave this open for now. Now I want to show you how to fix this missing data. Very easy. So to fix that overlay, you just need to come into your user layers, and you will go to your infiltration, click the edit button, click the node tool, and then we will select these guys. I see how I've selected all of those nodes, and then we'll pick one of them up. So you click it to pick it up, and then wait a sec. Okay, let me escape, and I want to get this one too. So we'll click it, shift, and then we'll click it to pick them up. You can click any one of them. You'll click to pick them up, and then you can move them out here, and then click to drop them. And that, or you can just make your own polygon right there. You can do whatever you want. And now that is ready to go. And so now I can, let's see, I can just save that, and I can process that again using the schematize button. Okay, now what we'll do is we'll go back to our table, and we will refresh this table. And now you can see that those missing grid elements were filled in. And that's how you process Horton data. Now I'm going to export the Horton data so you can see the data files. So that would be export DAT files, except you probably want to make sure that you have turned on the infiltration processing switch before you run export and run, but we're just going to export to look at the data. We're not going to export and run. So then we export the DAT files, and I'll just pop them in here, and you click select folder, and we don't need everything. We just want to see infiltration, and click OK. And then we go to that folder, and we see here that this is our Horton infiltration data, but something's missing from this file that we haven't fixed yet in the processor. So we need one more variable, and I think it goes right here, and that's your initial abstraction. So if you need to add an initial rainfall abstraction to Horton, Jim O'Brien modified the Flow 2D engine so that you could use initial abstraction rainfall with Horton, and I think it goes right here. But I'm going to check the data input manual real quick just so that you know for sure. Data, oh, I already have it open, don't I? Okay, data input manual. And yeah, it's on line 2. So line 2 would be initial abstraction, and then our Horton lines would be line 10. So it would be infiltration method, initial abstraction, and then Horton. So when we release the engine, or sorry, when we release the plugin, that will be fixed, but I just haven't gotten to it yet. All right, now, so then if you save this, and then this file is now ready to go. So be careful with Horton, because if you overwrite that, you'll have to put that back in. So be careful when you use Horton with plugin version 115. All right, so that's Horton. But now I have to delete that Horton data because I want to shift gears and go to SCS. So I actually have to delete this data out of this file. But that's not going to be your problem because you're only going to use one type of infiltration probably, unless you're doing something for Pima County. Then you might use a combination of Green Amt and SCS. So let's hit edit, and then we'll hit delete. This is the schema data, and then we'll save. So what I just did was I took this data out of this schematized data and I deleted it because I don't need it anymore. And then then I can actually turn those layers back off, because they do kind of make a mess of your layers and make things harder to find. So I go ahead and turn those off when I don't need them. And now I can move on to a different kind of editor. So I'm going to uncheck the infiltration areas, and we will now go into the SCS method. So SCS method is just your SCS curve number. And again, your global data does not, if you wanted to set up global data and just use a uniform SCS, you would just change that value right here. Now your initial abstraction is it's kind of like a modifier, because curve number data has its own initial abstraction. And its initial abstraction is dependent on the curve number itself. So this is a modifier. So I think the way this works, let's see, it says SCS global floodplain rainfall abstraction or interception. Assign this variable to 0 for automatic computation of initial abstraction. And I think, I'm not positive, but I think, if I remember correctly, that the way this works is if this value exceeds the value that is calculated, it will use this value. But if it doesn't exceed the value that's calculated, it will use the calculated value. So you do need to be careful with applying this value. I would only apply it like if I was using 1 or 2 different curve numbers. And so I'll leave it at 0 and click OK. I need to get off of this, so give me a second here. Okay, there we go. I just wanted to get off of that rubber band, because otherwise it would be rubber banding all over the place, and that's kind of annoying. So let's just get back to our project, and let's start looking at, so now we've set up our global SCS. So let's start looking at what happens when you apply global SCS. So now we can ignore these guys, we're done with those, and we can, now what we'll do is we'll calculate the curve number. So you have 3 processors here to calculate curve number data. One will use a single shape file, a single polygon layer, not necessarily a shape file, because these geo packages are also polygon layers with polygon, just layers with polygon geometries. Or you can do it from a polygon layer with multiple fields. That's kind of the Pima County method, but I don't recommend this because Pima County has their own processor. So if you're doing a study in Pima County, use their processor, and then you can just use this calculator either with a raster or with a polygon layer. Or you can use a raster, which is just applying it's just like the elevation raster. It takes a GDAL warp and it processes the data using a weighted average. Okay, so let's hit cancel, because you can't use this calculator unless you have curve number data. And the most common way to get curve number data that I am aware of is by using the curve number generator. And the curve number generator is a processing tool. So if you come here, let me see, curve number generator. Okay, let's remove these guys real quick so that we can process them again. Okay, and then I'll grab onto that layer, and then I will open the processing toolbox, and see here what I've done is I have merged or docked the processing toolbox with the Flow2D widgets. so that you can access them pretty quickly. And what we want, and let's clear this filter, what we want is the curve number generator. And the first time you use it, it's going to ask you for your email. And the second time you use it, it won't. So you have some instructions here that talk about, you get a video tutorial, description of the algorithm, and a lookup table that you can modify. So if the lookup table that is that is applied with the curve number generator is not the same variables that your county uses, you can control this lookup table and you can use your own data that your county uses. So if you were doing this for Pima County, they probably have a slightly different lookup table than what the TR55 recommends, and so you would be able to use your own lookup table. Now what you need to do is set the area of interest to grid. And there used to be a limit to how much data you could download, so you used to have to do this in like sets if you had a really big project, but I think they have modified it and it's a much larger, the project can process much larger area now. So this is the NLCD land cover, so we can click Save to Temporary File. And this is the NLCD impervious surface. And again, we'll save that to temporary file. And this is the soil data. That's here from your Sergio website. I don't know if you're supposed to say it like that or not. That's just the way I say it. And this is the curve number. Save to temporary file. And we'll click. And actually, what you probably want to do is actually save this one too, because this is the actual file that you want, to keep with the project. So you can save that to a curve number file. But I'm not going to do it because I've already done this multiple times, so I already have all that data. And you click Run. And when you click Run, it will write all of the data. Now, of course, obviously, if your project is large, that's going to take longer. So unless you get an error message, just wait for it. Another thing that might happen is that the databases might be down for maintenance or offline, and I think if you had a database that was offline, you will probably get an error message saying, hey, this database, I couldn't connect to this database, try again later, or maybe restart your computer, or maybe restart QGIS and try it again. So it does have some issues in that regard. Now we're finished, so we'll click Close, and what you see, let's just do this. I'm going to collapse all, and then I'm just going to open the curve number generator fields so that we can kind of cover these individually. And what else is here? We got that? Okay, perfect. So what we get from the curve number generator is you get NLCD impervious cover, so that's just percent impervious, and it's percent impervious from 1 to 100, and it's not very resolute, right? It's 30 by 30 meter resolution on the NLCD. Or you get the NLCD land cover, which is just a it's a single band variable, or a single band raster that tells you a different number for different bands depending on what that land cover type is. So, and as you can see here, we have a lot of, let's use our identification tool to see what these are. So we have a lot of 24s, which is high intensity development. We have some 22s, which is low intensity development, and we have some 21s, which is development but open space. So it's fairly decent data, but it's not very, it's better for like or it's not so good for urban mapping. It's better for like I would say farm mapping or solar panel modeling, or solar array modeling, or maybe wind array modeling or things like that. Okay, better for that kind of stuff. I guess wind generation is not an array. And we also have this is just the soil data from the Sergio website, so it goes onto their website and it connects to these different that website has a database and tables, and the different tables can be tied to these polygons, and then the data for these polygons can be filled from different tables. And there's probably like 40 or 50 different tables, and a lot of them are more dependent on agriculture and mining and stuff like that. But for the ones that we use, it's not very good to review it from here. But basically what you have to do is you have to search these individual variables on the table, and then you can see where that table is located. But what we do with, and I'll show you what our calculator does in the green app, so I'm not going to discuss that right now. And then you get your curve number data, which takes all of these three data sets and processes them into a curve number data using the lookup tables. So you can see here that you get this is your hydrologic soil group, land cover number, and then the grid code. So 22B will tie into a lookup table for this curve number, and then different processors, if it's A, B, or C soil type, you know, that would give you like how penetrable or impenetrable that soil type is, and then you'll get a curve number from that lookup table. And so and this is your curve number field. This is the data you use for the Flow2D processor. So what we need to do is check on this layer. This is the spatially variable curve number data for this layer, and then we go here to Flow2D and we start the processor. Wait, let's get rid of this ID tool. Calculate SCS curve number, and this goes to curve number, and this goes to curve number, or this goes to the curve number layer, and this goes to the curve number field, and you click OK, and that is going to give you a weighted average of the curve number data. But the processor does not like janky polygon data. So if there's any weird polygons or messed up polygons in your map, then you're going to have problems. Now, it doesn't seem to have any problems from the curve number generator. That data seems to be applicable. But if you get that data off of a different website, like if you generate this data yourself from a different website, you might get some errors. So if that's the case, you're just going to go and you're going to use the rasterize tool, or sorry, the curve number from a raster layer tool. Okay, so what you do in that case is you take your polygon curve number layer, use the processing toolbox, and search for the word rasterize, and you have here a vector to raster tool. Or actually, let me put in here, let's do that a little bit better, because you're not going to see recently used unless you've used it recently. So if I just put in the whole word rasterize, you can see here that I'm using this GDAL tools, and I want this one, vector to raster. And if I double click that, it will take the layer that I want, or you can drag and drop that layer in there. That's the best way to find it, because you know you have a ton of layers, right? So it's better to just drag and drop that layer in there. And then the field that we want to burn, of course, is curve number, and the value. Now this is just leave that blank. Leave this blank. This is going to be georeference units, and this will be 30 by 30 because that is the resolution of the curve number data that we got from the curve number generator. It also happens to be the resolution of our grid, but that's just coincidence. The output extent is important. This needs to be set to calculate from layer, set it to grid. I always set this to -9999, and if you want to save this data, you will save to file, but I already have one. If you don't want to save the data, you can just save to temporary file, and you click run. Oh, and I'll tell one more thing. This is the command for the GDAL command, and if you want to copy that as a Python command, you can use this, and then you can save it as a script so that you can do that more quickly, you know, with a script. Okay, so let's click run, and that doesn't take very long because it's not very much data, and you now have a rasterized curve number. And so if you go back to the Flow2D calculator, well, first of all, let's do this. I want to see how different this is. It's probably a mistake to do this in a live video, but I want to see how different this is. So I'm going to export my curve number data. So I click, I always lose this button. Let's go ahead and put this in curve number, and let's select that folder and export the infiltration. So that's coming from the polygon data. So let me rename that real quick. I'm going to rename that polygon. Okay, and then we'll do that again after we run the calculator. We'll process that from the raster. I want to see how different that is, and then click OK. Takes a bit more time than the polygon calculator because it has to process the raster and then it has to probe it. And then we export it again. And then let's open those two files in Notepad++, and let's just see how different they are. Okay, yeah, they're not too different at all. Nice. A little bit different in here for some reason. So let's go see why that's so different. Let's see. Yeah, they're quite a bit different right here. Oh, you know what though? I bet you one of my processors limits it to 63. I bet that's the issue. Let's see. Let's see about that. Let's go to this grid element number and let's probe this raster. Let's probe that raster. Yeah, because see, that's 52. Oh, interesting. So be careful about that. I'm gonna have to add that as a yeah, that's not quite correct. So let's print screen on this. Well, I'll do that later. I'll do that later. I'm gonna make that an issue, but I'll do that later. So be careful with that. Because you may not want that to be limited to 63. So we'll have to sort that out. Okay, so let's see, let's just zoom in on this again. Let's get that back to where it was, and we are basically finished with the infiltration calculator. So I will stop this video here, and the next video will cover the green amped calculator.